Alright, good morning, guys. So, chapter 3, in my opinion, is one of the easier chapters that we do, so hopefully you find it easy. So, pairs of lines and angles. So we have a couple postulates. One's called the parallel postulate. So if there is a line and a point not on the line, then there is one line parallel through the point. So I've got some line over here, got some point, P for point. So I have a line and a point not on the line. There's only one line that is parallel through that point. Okay, so how would that be used? It would basically be like, is this line parallel to this one? And you would be able to say yes or no based on if that was the only line through that point. So if there was, some other line, is the green one like parallel? No, because the red one's parallel and there's only one line that is parallel. Okay. I maybe should have used a different color for the red one because I wanted to do something, but let's make this blue. So how do we know lines are parallel? There's these little arrows. In the book usually does them like red. So if you see arrows like that, kind of pointing the same direction, then you know the lines are parallel. In the directions, if it says, hey, this line's parallel to this line and it's not marked, then they're parallel because it told you in the directions. But typically, they will be marked. All right, so then postulate 3.2 is called the perpendicular postulate. And from now on, I'm going to abbreviate perpendicular. That is the sign for perpendicular. Kind of an upside down T, I guess. So it says the exact same thing as the other one. It's on page 127. I'm not going to write it down. If you have a line and a point not on the line, then there's one line that's perpendicular through the point. So it's the exact same thing as the parallel one, just with the word perpendicular instead of parallel. So if we have some line and we have point P that's not on the line, then there's only one line. Sometimes it goes on past it, sometimes it doesn't. How do you know it's perpendicular? You'll see the box. Okay, if you don't see the little right angle symbol or the little box thing there, it's not perpendicular. Well, it looks like it. We can't say that. It has to be marked, because by looking at something, if it was a measurement of an angle that was 90 degrees and then another one that was 89.5, you would not be able to tell the difference just by looking at it. So you have to have that little box to say that it's perpendicular. Okay. All right, so we have some, I kind of skipped ahead because I want, and I'm going to go back like in terms of the order in the book. So if we really want to define parallel lines, I guarantee you're going to leave out something. If I said, what's the definition of parallel lines? Many of you would say lines that don't intersect or don't cross or don't touch. And you're almost right. Because I can draw lines that are not parallel and they don't touch. So we have to do 3 dimensions to do that. But so parallel lines are 2 lines that don't intersect is the formal mathematical word. And are coplanar. They have to be in the same plane to be parallel. Because we have these things called skew lines that are 2 lines that don't intersect also, and are not coplanar. So it's kind of hard to draw on like a, it's much easier to like kind of, so if you visualize whatever room you're in, the floor and the ceiling are parallel. They don't touch. So if you drew a line across the wall from right to left, and then you drew another one across the wall right to left but lower or higher, they're in the same wall or they're in the same plane. But if you drew a line across the wall from right to left, and then you drew a line across the floor in the opposite direction, so going toward the wall that you drew the line on, they would not cross. But they are not parallel. They're going in different directions. So that's another way to kind of look at parallel lines go in the same direction, the skew lines go in a different direction. So if we used this a cube, and I think you're going to have some problems with a cube also. So if I said parallel to AB, all the ones going in the same direction so CD, EF, GH. They're all going front to back. They're all going in the same direction. Now, AB and CD are both like in that top like part in that plane, and AB and EF are on the left side. GH is the harder one because there's not a plane there, but I could draw a plane that goes diagonally through the cube, and they'd be, parallel, or they would be in the same like plane. Okay, so if I said skew to AB, we're looking for different direction. So AB is going front to back. Skew lines aren't going to go front to back, and they're not going to like intersect with AB. So I would have FG. That's going side to side, and it's on the bottom. I would have EH. Okay. Same thing. It's going side to side. It's on the bottom. I would have DH. It's going up and down. And I would have CG. Again, it's going up and down where the AB is going front to back. Okay, so your first few sets of problems are just going to be, which lines are parallel to CD, which lines are perpendicular to CD. So remember, perpendicular, you're looking for, and here's kind of a contradiction. I said you need to see the box that's telling you it's a right angle. When you're looking at a cube, kind of by definition, it's going to be perpendicular. So you can assume by looking at the picture, that lines are perpendicular at basically all the corners. So you're just looking at different figures, okay? All right, now pairs of angles. This is hugely important. If you can't do this part, you're going to struggle with the second and the third section. Okay, so if I've got these two lines, and then I have a third line. Okay, so first thing, this line that goes across the other two is called a transversal. So that's kind of an important indicator, but okay, so if we have angle 1, 2, 3, 4, 5, 6, 7, 8. We have pairs of angles. So there's 4 of them, different pairs. Okay, so first we have corresponding angles, and this is the one that you kind of need to, the name of the angle doesn't necessarily, well, I'll show you what it means here in a second. I think corresponding is the same spot. Now, what I mean by that is you're going to have this group of 4 and this group of 4, and we talk about corresponding, all these, the 4 different sets of angles. They're all going to include one from that top set of 4 and one from the bottom set of 4. So when I say the same spot, what I'm referring to is like angle 1 and angle 5 are both in the top left-hand corner of their group. So angle 2 and angle 6 are on the top right-hand corner of their group. Angle 3 and angle 7 and angle 4 and angle 8. Okay, so there's 4 pairs of corresponding angles. Same spot, top right, bottom left, whatever that location is. Okay. All right, now the rest of them, the names of the angles kind of help know where they are. So we have alternate, interior. I want to split that apart. I'm going to erase it and write it again. too good this morning. Okay, alternate interior angles. So the reason I split it apart is alternate is the location as it relates to the transversal, and interior is where it is in relationship to the lines. Okay, so alternate means like opposite side, interior means on the inside. So for alternate interior, we'd have angle 3 and angle 6. Okay, angle 3 is on the left side of the transversal, angle 6 is on the right side of the transversal. Interior, they're on the inside of the lines. Okay, so I'd also have angle 4 and angle 5. 4's on the right, 5's on the left, they're on the inside. Okay, so then the other one is alternate exterior. So angle 1 and angle 8. 1's on the left, 8's on the right. They're on the outside of the lines. Angle 2 and angle 7. 2's on the right, 7's on the left. They're on the outside. Okay. All right. And then the last set, consecutive interior. So consecutives like in order, but so they're on the inside because the interior. So angle 3 and angle 5. So they're not alternate, so they're not on the opposite side. There are some books that call these same side interior angles. So that's another, I don't think it's used in this book, so I don't want to write that down. But you can, if you want to try to remember for the last one, they're on the same side. And they're on the interior. So your last two sets of problems, one set will be this almost identical picture, and then it's just going to say which ones are alternate interior, which ones are alternate exterior, which ones are consecutive interior. Then you'll have the last set will have another picture, and it'll just say angle, like problem number 15, angle 5 and angle 1. What kind of angles are they? And so the answer's either corresponding, consecutive interior, alternate exterior, alternate interior. So you're just labeling them. Okay, but I'm going to make a comment that if you cannot identify in the picture that you're looking at on the screen right now which ones are corresponding, which ones are alternate interior, which ones are alternate exterior, and which ones are consecutive interior, you are going to fail this chapter. Because it's only 4 sections long, it's really fast. And 3 of the 4 sections deal with the first thing you need to be able to do is say those are alternate interior, and then you may do something with it. Okay, so it's super important that you be able to identify the different angles. Okay, so really spend some extra time studying that part of it. All right, so assignment today, there's really not any work to show. It's just simply identifying stuff. Tomorrow we'll have work to show. But all right, have a great rest of your day, guys. Talk to you later.